Okay, where we left off, I think we did the synthetic division problem, right?
Yeah.
And then I think we didn't get to the long division problem though. So let's take a quick look at the long division problem. And this is a little bit of a process, so let's take this one from the top. And the answer that I'm looking for on this is the actual, I want you to write in the whole answer. So what is, if I divide these polynomials, what do I get back? And so you're going to have to use, you're going to have to use this display response box to make sure you have it input correctly. Okay, so let's take a quick look. All right, so if I'm trying to find this quotient, and I'm going to use long division. So I've got this numerator and then this smaller denominator. Now, which one, when I'm doing my long division, goes out front? The second one. Good. The denominator always goes out front. Good. And there's a couple things we got to do here to really get organized. The secret to doing polynomial division, long division successfully, is definitely taking your time and being very methodical and deliberate and neat. So you got to use lots of paper to do these. Okay, so inside we've got this guy, right? And out in front we have the numerator. So x squared, what the heck's x squared.
So we don't need a calculator for these.
No, these you won't, the calculator won't do any good on these. Yeah. And then inside we'll put this guy. Now remember, we have to, in this case it's not an issue because there are no missing terms. Okay, I don't want to see any phones out. You guys have been pretty good this period about that, but I want to have all phones away. Everyone's got to be focused on this big time. Okay, so we don't have any missing terms, but if we did, remember I have to have a column for each power of x. That's essential. If you don't do that, you're guaranteed to get this wrong. So 3x squared, cubed, minus 8x squared minus 8x plus 7. Okay, so how do we start this off then? How do we do long polynomial division? Good. Okay. Good. First term outside divided into first term inside, right? And so we just have to answer the question then, what is 3x cubed divided by x squared? 3x. So 3x is the first part of our answer, right? That's the first term in our answer. What do we do when we get a new term on top?
Subtract it.
Okay, well, we gotta
Multiply.
multiply it through. Good. So this guy is gonna get multiplied through, distributed through to all three of those, right? And if we do that, we get 3x times x squared, 3x cubed, right? And those have to be that way, so they'll subtract to 0. 3x times 2x,
6x squared.
good. 3x times negative 1. Okay, now tell me exactly what to write, because this is important. This is where people make mistakes. Say it again. Okay, but before I do that, what do I write on the paper?
Cross out.
You're missing something.
Oh my gosh, I don't know.
Minus the quantity. You gotta put that in parentheses, because if you don't, what people tend to, they'll subtract the first terms, but then they get messed up. Is this supposed to be added or subtracted? Did the minus sign apply only? No, it applies to all of it. We're subtracting the whole thing. So to remind yourself of that, you gotta put this polynomial in parentheses and put the minus sign out front. Then you get in the habit of saying 3x cubed minus 3x cubed cancels. Negative 8x squared minus 6x squared is what? Negative 14x squared. You got to be real careful about those signs. Minus 14x squared. So negative 8x minus negative 3x, negative 5x, because we're adding the 3x. Right. This is the part that you got to be real careful with. Right. And then I just bring the 7 down. Good. Okay. So next step.
Did you say negative 5x?
Say it again.
Did you say negative 5x?
Oh, I did. You're right. Thank you.
Ooh, way to catch you. Black ones.
Good, good. Okay, now what?
Negative 14x squared divided
Negative 14x squared divided by x squared equals negative 14. That's my next term. Okay? And I distribute again, right? So negative 14 times x squared is negative 14x squared. Negative 14 times positive 2x, negative 28x. Negative 14 times negative 1, positive 14. And then what do I write?
The negative two thingy in the front.
Subtract the quantity. Good. So negative 14x squared minus negative 14x squared cancels, right?
Yes.
Negative 5x minus negative 28x. Positive 23x, because we're adding the 28. Good. Okay, and I'm going to make this a different color. I'll make this green. You'll see why. So this is going to be positive 23x, 7 minus 14,
Negative 7.
negative 7. Now, does x squared divide into 23x? No, so this is my remainder, right? Agreed? Okay, so then my answer, this is the answer. I just have to write it in the correct form. So I get, this is the polynomial part, right? So that's going to go first, 3x minus 14 plus, then I got to put a fraction bar. Where's the remainder go? On top. Good. So the 23x minus 7 just goes right there. And what goes on the bottom? Yeah, good. The original denominator, right? Which is right there. Okay. So x squared plus 2x minus 1. Now, how do I enter all that in Moodle? Because I've got to put all that in Moodle. Okay, so in Moodle, I'm going to put in 3x minus 14 plus, good, the quantity, 23x minus 7 divided by the quantity,
X squared plus 2x minus 1.
x squared plus 2x minus 1. And remember, what I always want to do on these is hit the display response and just see if it pops up right. Because then you'll see the math view here, and it should look just like what you have on paper. Okay? We good? All right. Okay, last two, very quick. This polynomial, f of x equals ax to the fourth plus, who cares, has at most how many real solutions?
4.
4, right? Because the degree of the polynomial is 4. So that's how many total solutions it has. They could all be real, or I might have some imaginary ones, right? But at most, I would have 4. Okay? And then last one, when a polynomial of function of least degree that has real coefficients, a leading coefficient of 1, so now all that stuff says, don't let that confuse you. All that means is, the way we described it in class, all this stuff just means simplest. So the simplest polynomial we could build from these zeros is what? How would we do that? Let's take a quick look at this one. So, okay. So they want to know then, if I build a polynomial out of this, the question asks, actually just asking, what's the coefficient of x squared? But how do I build the polynomial? If these are my 3 zeros that I'm given, what do I do with those? This is stuff we went through yesterday, or maybe the day before, I can't remember. Day before. So these are my zeros. X equals 6, x equals 7.
Don't you put them equal to 0?
Okay, yeah, I'm gonna turn them into factors. Good, so I'm gonna turn each of these into factors. So my polynomial then Yeah, good. It's just gonna be the product of x minus 6 times x minus 7
X two.
times x minus 2. And all I've gotta do now is just multiply that out.
X times X.
So what if I took these two and FOILed them out? I'm gonna get
X squared.
x squared minus 2x minus 7x
Plus 14.
plus 14, which I could simplify, and I wanna do that. I've got these two like terms I could combine.
Negative 9x.
So x squared minus 9x plus 14, and now I can distribute through that small polynomial. Okay. And so if I do that, if I distribute the x all the way through, I'm gonna get, x cubed minus 9x squared plus 14x. I wanna make sure I keep a column for each power of x, right?
Minus 6x squared.
I distribute the negative 6. Then I'm gonna get my minus 6x squared, so it goes in that column,
54x.
plus 54x, good. And then minus 84. Okay, and if I'm just looking for, remember, now that answer, when I add those up, is my polynomial, but all it really wants here is the coefficient of x squared. So, normally I would add all those up to get the whole answer, but all we really care about is that column, right? I'm just trying to get you guys in the habit of making sure you get the columns right. So what's negative 9x squared minus 6x squared?
Negative 15x squared.
So we enter the coefficient, so what is it?
Negative 15.
Negative 15. Okay. Good. And that's it for the non-graphing calculator test. So if we put in that negative 15, let's just check ourselves here. Negative 15.
Does this deduct points?
I don't think the review does. The test obviously does. Yeah, it's fine. Okay, so there's the non-graphing. Let's look at the graphing calculator one, and you're going to see that this, you can really use your calculator to do everything on this one. And I'll just pull up a calculator, and we'll just go through it,
Let's do it.
piece by piece. Okay, so what about this guy here? Now, how could we use a calculator to evaluate this polynomial when x is 4?
Don't you go like X and then like
You
enter?
type that in and then push
I was getting to that.
Perfect, perfect. Okay, there's a ton of ways we can do this, but the easiest way is just to literally store x as 4
Yeah.
and then enter that expression and hit enter, and it'll put that value in for x. I could just put the x in parentheses if I want to. I could just put a 4 in parentheses in there for each x, and that'd be fine too. I could even graph the thing and, and hit second calc value, but that seems like a lot of work, right? The easier just to go 4 store x, so it's in there, and then just enter this expression, 4x to the 4th plus, whoops, don't do that,
3x
plus 3x cubed minus 4x minus 7. Okay, and just hit enter, and boom, there it is, 1193. Okay.
Easy squeezy lemon squeezy.
Store is STO, right there. Okay. And once again, if you forget that, just every place there's an x, just put in a 4 in parentheses, and that's fine. So I could have had just a 4 squared, a 4 cubed, minus 4 times 4. It does the same thing. It's just more buttons to push. Okay? Next one. What about this guy? So when these polynomials are added together, what's the leading coefficient? So really the calculator doesn't help you a ton here. If I'm adding these things up, now you don't have to do all this work. Be smart about this. You can outsmart this question a little bit. I encourage you to do that stuff when you can. If I were to do this whole problem, I've just got to add up all the like terms. I'm going to get a huge string of like terms. But if I'm only looking for the leading coefficient, that's just the coefficient of the biggest power of x.
16.
So if I look at all the powers of x, yeah, I see that there's an x to the 16 and there's an x to the 16. And every other power of x is less than that, right? So we can just add those up. Yeah, so what's 3x to the 16 plus 14x to the 16?
That number.
17.
Yeah, I'm gonna get 17x to the 16th plus the rest. So all we care about is the 17, that's the leading coefficient. Okay.
Wow.
No big deal.
You saved like 20 minutes.
We saved some time. Okay, what about this one now? When these polynomials are multiplied, once again, this is a lot of work to do, isn't it? But a lot of times, when we're dealing with polynomials in real life, all we care about is what's the biggest term. A lot of times that's the way it is. And so when these are multiplied, if I, once again, just want to find the leading coefficient, there's going to be a ton of work to do. But when I distribute this thing, the 9x to the 12th all the way through, wouldn't you agree that I'm just going to get one really big power of x and then a bunch of other smaller powers of x?
Yeah.
And when I distribute these other lesser terms, I'm always going to get smaller powers of x than that original first distribution, right? Everybody see that?
Sure.
And so the leading term is just going to come when I distribute the biggest power of x in the first polynomial to the biggest power of x in the second. So I'm going to get 9x to the 12th times 10x to the 12th. Okay? So I get 90, and then if I multiply like basis, what do I do to the powers? Add the exponent. So I'm going to get 90x to the 24th. In this case, they just want the leading coefficient, which would be 90. Okay? Oops. Okay, what about this? Now, the same kind of question. This time they want to know what's the degree of the resulting polynomial if I multiply these out. Yeah, biggest power of x.
When you just add those to 14, that's the answer.
Same thing we just did, only this time, instead of wanting the coefficient, we want the power of x. So we're going to take the biggest term here, distribute it to the biggest term here. Gives us 6x to the 13 times 23x to the 6th, right? Well, 6 times 23 is 138.
Wait, isn't it the?
It's 23 to the 14th, isn't it?
Oh, 14th, whoops, my mistake. So, oh, where's that? Oh, I saw the 6th there.
Oh, something.
So I'm going to get 6 times 23 is 138. X to the 13th times x to the 14th is x to the... So what am I entering? 27. That's the degree, right? So we're getting there. This one will go very fast. Okay, what about this guy? Calculate the product of the three binomials. In the resulting polynomial, what is the coefficient of x squared? So this time you're kind of stuck actually multiplying them out, aren't you? But it's no big deal. We're just going to multiply. I won't even do this one. Let's just talk about how we would do it. I'm going to multiply out two of them. Take your pick. Doesn't matter. I'm going to FOIL out two of them, simplify that answer, and then distribute the 3x plus 7, right? Isn't that the very same work that we just did right there?
Yes.
Well, it's a little different context. You got to recognize it's the same work. But all we're doing
How do you
is just multiplying out three binomials. Take two of them, simplify it, distribute the third. That's all they're asking.
And we do that on paper. You don't want us to try to do this like somehow.
No, do this on paper
Okay.
for sure.
For shizzle.
Yes. Okay. Oh, look at this. 4 more problems and we're done. See, this is no big deal.
No big.
This one is easy. Okay. Find the greatest real zero of the function. If there are no real zeros, enter 999. Now, this is great. You're loving this problem because all they're asking you for are the real zeros. Now, here's the thing you got to remember about that. The real zeros on a graph always correspond to what? Well, there could be more than one. If we're looking for the greatest one, we're looking for the rightmost what? When you say the right one, right what? What are you talking about? Real zeros on the graph I recognize because they're equal to what?
0.
Well,
X.
x squared.
No.
X on the.
What am I gonna look for on my graph? The real zeros of the function.
Will it cross X?
Ah, the x-intercepts. There you go.
That's what I
Exactly.
was trying to say. 0 at X.
Okay.
Same thing.
Real zeros are just
Whatever. Smart.
x-intercepts. Obviously, the imaginary zeros aren't gonna show up as x-intercepts, but we don't care about those. All they're looking for are the real zeros. So what do we do on this one? This ends up being a really simple problem. Graph it, find the x-intercepts. Okay, now how do you, and so you run into all the typical old graphing problems that you always run into, but you're getting a lot better at this. Now, if all I care about are the x-intercepts, let's put this one in to y equals, okay, 3x to the fourth, thank you, minus 2x squared plus 5. Oops. Plus 5. Okay, now, to find these things, now first of all, how many could we get at most?
4.
4. Okay, so we can get 4 of these at most, right? So let's take a look at the graph. If I go up to the window, now what I want to do is I want to go ahead and set the x's. We're going to set the x values. So let's just go from, how about if we make the x, the domain pretty big? So let's go from like negative 20 to positive 20.
Positive 30.
Okay, and let's just hit zoom 0. And then the calculator's gonna, it'll pick the height of the window for us. And then we might tweak that a little bit, but if I go zoom 0, okay, there's what it did. So all the action is occurring in here, isn't it? So going from negative 20 to positive 20, everything significant happened in there. The graph is way flattened out though, because look what it did when the calculator picked the window. Y minimum is pretty small, but Y maximum is almost 500,000. Right? You see that? That's really, that's making it really skewed. So let's just go in there and let's make we want to be able to see the x-axis, which we couldn't really see. It was squashed into the bottom. So instead of going from, roughly 5 up to 500,000, how about if we just make the x-axis in between the two? So let's go down and do something like, how about just negative, we'll just go like negative 50,000.
Oh.
And that's, you could pick almost anything. So negative 50,000 to positive 50,000. And I could have probably just gone negative 1,000 to positive 1,000 too, but if I do that, okay, now we can see the x-axis. Clearly, everything we need to see is right in there. So we just have to take a little closer look in there, right? So how about if we, I'm just gonna go, there's a ton of ways we could do this. Let's go zoom box. If I do zoom box, I can pick what my window's gonna be. So let's just go up here and draw a box that's going to be our whole window. Up to about there. Whoops. So I'll hit enter. Go down below and just do something like this. That's going to be my window now.
That is so cool. It's awesome. Is it really? It is.
Oh, come on, stop. This thing just, it lags so much, it's hard to. Okay, anyway, let's just try that. Okay, so
2.
we're getting better, right? That's looking pretty good. I might even do it again. Now what's, say it again?
What are you trying to look for?
We're just trying to find where the x-intercepts are. Okay?
It's 2.
So this is going from negative 1, 2, 3, 4, 5, 6, 7 to positive 7. What if I just made that go from like negative 1, 2, 3 to positive 3? I mean, this takes a little time, but once I get this thing figured out, negative 3 to positive 3, and my y's, I'm just going to go from negative 100 to positive 100. Oops. There we go. Okay, it looks like it's maybe hitting right there and there. Those are the only spots though. Everybody see that? It's gonna go from -10 to +10. Does it cross?
No.
Never crosses. So what's our answer? 999. How about that?
That's the only way to figure out the answer, but
Well, no, you could do quadratic formula too if you wanted. That's fine to do,
not really that.
right? So this one is 999.
So we could have just put zoom 6 and it would have showed us that right off the bat.
This one might have, yeah. Yeah. They're all gonna be a little bit different, but then what you'd also wanna do, how do you know, here's the other thing, how do you know that it doesn't turn around and do that? So you gotta at some point go out there a little further and see what it's doing. I probably took a lot longer, yeah, you're right, I probably took a lot longer on that one than you would, but you get the idea. Now, could we, what if you don't wanna graph it? Yeah, you could just solve this using the quadratic formula too, right? I could just put in A is 3, B is -2, C is 5,
We're experts at that.
solve for x squared, but then I gotta square root both of those, okay? Anyway, you see how, so those aren't hard, they're just time consuming. You just gotta mess with the graph until you can find the x-intercepts. So you gotta be patient, but if you're patient, you're guaranteed to get the right answer, so that's good. Okay, what about this? Okay, so what about this? Find the greatest and least real zeros of the polynomial. Say it again. Yep, just gonna. I won't do it, but you would. You get the idea. This is just to give you another one where you graph. Now, what it says, if you get only a single real zero. So what if it just grazes it at a vertex? Then you put it in for both. Okay. But that's just another graphing one. Can we skip it?
Yes.
Yes.
And then the last two. This is a gimme. Let's just do number 9 and get it out of the way.
Well, don't you do stat edit?
Yep, it's just regression. Just regression.
Oh,
It says
right,
find the
We got it,
coefficient.
got it.
You got
We
this
know
one?
it, we know
Everybody knows
it.
how to
We're
do
good.
it?
Still alive.
So you're just gonna put in these 4 points and do cubic regression, right? So you'll go stat edit, put in the 4 order pairs, go stat calc, go cubic regression, and then you want whatever's being multiplied by x squared. Calculator does it for you. And then the last one right here, and then we're done. Done with everything and you're ready to go. Okay, so what about this? What if we want to find the simplest polynomial when these are my zeros?
Isn't that the same thing we already did?
It is. The only difference here, and notice I wasn't mean. I didn't give you any really hard imaginary ones, but I did give you an I.
Oh goodness.
So if I've got these are my zeros, x equals 5, it shows up twice. Do I have to put it in there twice?
Yeah.
Yes, because both of those are going to be factors. I'm going to get x equals 5, x equals 5, and x equals 2i. Now, what's the missing one that I have to assume? Negative 2i. How come?
Because imaginaries come in primaries.
Good. Imaginary zeros always come in complex conjugate pairs, right? So I also have to include x equals negative 2i. Now, what do those factors look like? X minus 5, x minus 5, okay, and from here, maybe we don't even need to finish this one, but here's one crucial step. Which two do I definitely multiply first?
The 2 R's.
The i's, yeah. So if I do this, if I multiply these out, I'm gonna get x squared, and then I'm gonna get, I can even skip the middle ones, right? I'm gonna get plus 2ix minus 2ix, which will always cancel. And then negative 2i times positive 2i is 4i squared, which becomes positive 4i. Good. So I get x squared plus, positive 4, right? I squared is negative 1. So then I get x squared plus 4 times x minus 5 times x minus 5, and I don't think we need to go through that. You guys are, that's just a matter of multiplying them out, right?
That's simple.
We good? Okay,
To the left.
to the left.
Let's do fun games in here.
Yeah, we'll have 10 minutes, so let's just do a game or something.
Heads up, though, no.